Hi everybody, welcome to Promar. Today we would like to give an overview of the software that powers our CNC stone processing equipment. A few words about us. We create programmable engraving and milling machines for stone etching shops. If you're in the business of making headstones, this video is definitely for you. The company is new to the market, however, it has been established by a team of engineers with over 12 years of experience in this area and more than 5,000 units of equipment utilizing their knowledge sold worldwide. Let's begin. We turn the machine on, then we send the cutting head to the home point. There may be several machines managed by the same account, and they don't even have to be in the same workshop. Here's a list of registered machines. Once the machine is launched, we can use a keyboard to manage it or a gamepad. Here we have a setup menu. Here we have surface scanning options. Here we have transportation options at the safety height and the return to the home point. Here we turn motors on and off once the job is completed. Here we set the safety distance on the vertical axis Z. This is the height at which the cutting head travels back to the home point or makes its roundabouts. This is the manual speed. That's the speed that the cutting head travels when we manage it from the keypad or gamepad. Here we choose the type of scanning mode. This is the continuous scanner. These are the two sensors, one which detects the cutter overhang and the other one scans the actual surface. The scanner does not have to be located at the very point of the cutter. Here we have offset settings. The machine will make necessary corrections afterwards. This is the scanning height. Here we have set 2 millimeters, which means that from point to point the scanner will travel at the height of 2 millimeters. The switch allows us to set the safety height for a scanner as a maximum height of the vertical axis Z, which means that from point to point the scanner will travel at the maximum height. This is the speed correction. Machine data: how much the machine has traveled on different axes in millimeters, and total operating time. Here we have general settings. We can choose the language here. We can also check for available updates. Here we can turn on the Telegram bot, which will allow us to see what's happening with the machine, and if necessary turn it off. This is a button layout of the gamepad. This is the connection wizard. We can see a list of available machines. We can pick any one of them and do whichever operation we need, like upgrade firmware, for example. Here we can choose between the machines that are available in the network. There's only one lighted green, which means others are not connected at the moment. However, all the jobs that are being done on these machines, they're stored in cache memory, and we can restore them if necessary. The same program is being used for all types of machines by Promar, which means you can run both engraving and milling machines using this software. Switching between different machines works instantly, which means we can monitor either one of them online. Here we choose between scanning types. For example, if we scan by one point, the machine will touch just one point and then set the safety distance along the vertical axis Z. We can also choose a 3-point type of scanning, which is advisable to use in case of working with the 3D models. Using the 3-point scanning allows us to set up the inclination of the workpiece. To perform the scanning operation, we need to go back to the setup menu, and there we choose whichever type of scanner we want to use. After we do this operation in the setup menu, we'll have a selection of different scanning types here. For example, we can choose a point scanner. The scanning will be performed by contact sensor. This is the selection of the view type. That is how we are going to see the model. This is the top view, which is recommended for the binding operation. This is the isometric view. Here we can switch to the full screen mode. This option becomes active when the model is downloaded. It is placed in the center of the screen, and then the size of the screen is adjusted to the side of the model. Here we have scaling options. We can upscale or downscale the model. Here we can go through other view options. This is the markers menu. We can use markers, for example, to define the boundaries of the working area. This allows us to make sure that the cutting head will not go beyond the working area. We can place markers, or if we don't need them, we can erase markers to have a clear screen. Let's now add the object. Here we have the object. We can move it around, dragging it by the edge and place it in the working field of the machine the way we find convenient. Using this visual menu, we can bind the object to the cutting head. By clicking here, we change the binding. If we place the marker on the plate, then, by engaging this option, we can move the object along with the tool. This is how we unbind it. We can add several objects using G-codes, and then we can arrange them the way we like. We can do separate binding for each object. We can group them together. The object on which we perform the binding is the one that is highlighted. We can align different objects, linking them to the highlighted object. This option comes handy, for example, when carving is to be performed by a different tool. In this case, we need to make sure that the trajectories of different tools match. This matching is done by engaging this option. This menu allows us to move the cutting head along the 3-axis by setting the distance of such movement. For example, we want to move the cutter by 10 mm along axis X. The tool will move now. By clicking these buttons, we move the tool up or down the vertical axis Z. This one brings the tool all the way up. These buttons make the cutter move in the given direction. And this one in the middle allows us to use the mouse to point where the cutter should go. It can also be used to move the cutter to the marker. Let's see how it works. Let's move the cutter to some point away and then highlight the marker. The cutter will then travel to this marker. By clicking on the anchor button, we once again use snapping by selected object. The difference is that this time we are using a different coordinate system, the one that is built into the G-code. This type of snapping may be tricky as assignment of point 0 may be different in different G-codes. For example, some may set a center point for a 0 while others may set the upper left corner. So one has to be certain why they want to use this particular option for binding objects. After we establish this surface, we can move the cutter all the way up and all the way down until it touches the surface of the slab. Please note that the program won't let us start the machine if the object goes beyond the working area along whichever axis. For example, if we try to establish this surface higher than the machine allows, it simply will not start. The start button is inactive, and on the screen it is highlighted that we've gone beyond the boundary along axis Z. This is super convenient as the operator right away can see that the G-code cannot be performed under the current settings. This is the start button. This is the stop button. This is the work recovery menu. In case of an abrupt stop, there will appear an emergency triangle which will display where the operation was aborted. We can also resume the operation by choosing where the machine should restart manually. This indicator shows us the number of steps that have been performed. We have selected an increment which length is 0.1 mm. We can select several increments, this way it will be easier to see where we are at. Here we can see where the job will resume after we restart the machine. This option is particularly useful in case the cutter breaks during the operation, while the machine keeps running. So we'll need to go back to where it broke down. Thanks to this option, little experience is needed for an operator to resume and complete the job without any artifacts or signs of failure. This button forces the machine to resume work from step 0. The machine can be connected to the computer via USB or Wi-Fi. In case of an abrupt power failure, there is no problem to restart the machine from where it stopped. To resume work, in this case, we need to start the motors and send the cutting head to the home point, and then hit the start button. Here we see a warning triangle. It shows the position where the work was abrupted. The machine retains the coordinates, so after the restart, it will go exactly to the point where it left off. The machine detects possible failures of the frequency controllers, so in case of failure of an external device, the machine will stop. Scanning. Here we have a lettering job. It cannot be performed correctly without surface scanning. We have a surface indication here which shows 0. This is because so far we used a one-point scanning. If we run a 3-point scanning, the machine will calculate the degree of the surface inclination. In order to define the plane, we need to select 3 points on the edges of the G-code. This will allow us to define the inclination of the surface. Here we have a 5.1 mm slope. With a maximum cutting depth of 0.3 mm, it is obvious that with such a slope this text cannot be engraved, as the inclination is more than 10 times greater than the maximum depth. In addition to this, when performing a lettering job, we should use continuous scanning. It is because after polishing, the surface of the stone will always have some uneven areas. G-code. What can we do with the G-code? Here we can select the bypass type. Here we have a frame type. The two other options are fast and accurate types. Depending on the kind of the object, the bypass trajectory sticks to its edges. Here we have speed regulations. We can increase or decrease the speed. Here we have the position of the object indicated. We can also increase or decrease the size of a G-code. This function can be very helpful in certain cases. However, in order not to lose the precision of fine detailing, it is advisable to keep the alterations of the G-code within the limit of maximum 3 to 4%. Here we can rotate the object to any angle. We can rotate it by 1 degree or, for example, to 90 degrees. This function is very useful when working with heavy slabs. Instead of turning them around, we can simply rotate the object. This is the correction on the vertical axis Z. We can use it when we replace the broken cutter with a new one, and therefore we may need to adjust the vertical change. It can also be helpful as the cutter wears out, and small adjustments may be needed. This is the size indication. The machine maintains information about the projects that have been performed. They are stored in the computer. Here we can copy any project from the past, make necessary alterations, add or remove G-code items, save, move to another machine. These are more or less standard copy-paste operations.